All right, welcome to worksheet number 9, chain rule. This corresponds to textbook section number 2.5. In this section, we'll talk about how to take the derivative of composition of functions. Composition of functions is just, that means you are putting two functions together to create like a new function. For example, we know how to take the derivative of x squared. We know how to do that. That's just 2x. And then we know how to take the derivative of sine x. We just talked about that last section, which is just cosine x. But how about when these two functions are composed, which is basically one example could be sine x, the whole thing squared, right? So it's not x squared, but it's not just sine x, it's just sine x, the whole thing squared, right? So here we use the chain rule to find the derivative of the composition function. Let's look at the first example. Let y of u is equal to u squared, and then u of x is x squared plus 3x. It's like, you're thinking, why are you using u here, and then why are you using u and x? When we have a composition function, basically where you're putting one function inside the other function. That means you're using one function as a variable for the other function. So I see u here, but the first one, u is like the variable, right? So this is what I mean by a composition function. That's when we talk about composition function, you'll see like different variables. So first, y of u. So now it's not y. Usually we have like x something, but here we u something. But what's u? U is in terms of x. U is actually x squared plus 3x, right? So you're kind of you're plugging in x squared plus 3x into the square function. So here I want to try to find dy dx. So when we have multiple variables like this, there's y, there's u, and there's x. Sometimes it's kind of important to notice, like indicate what are you taking the derivative respect to, like what is your variable going to be. So here we specifically write dy dx. Many times we see it as just y squared, y prime, right? But here we're just making it a little bit more specified. All right, so what do you need to do? First, we need to figure out the y of x. Because I want dy dx, I don't want the variable to be u. I want the variable to be x because they specifically ask for derivative with respect to the variable x. Okay, so I'm going to rewrite this. Okay, originally it's written as u squared, but u is something else. So this is what I'm going to do. It's u squared, but u is x squared plus 3x. So what I can do is that's just x squared plus 3x, the whole thing squared, right? So instead of writing u, I wrote x squared plus 3x. And then instead of writing u squared, I wrote the whole thing squared. Okay, I know how to FOIL this out, and I can rewrite it. I can do it long way, or if you know the shortcut, you can do shortcut way. So this is going to be this is x squared, x to the fourth. You get 3x cubed, so that'll be 6x cubed, and then plus 3x times 3x, so that's 9x squared. So when you multiply it all out, I get 4x squared, 4x to the fourth plus 6x cubed plus 9x squared. Right, so that's my, so if I were to rewrite u in terms of x, I'm sorry, y in terms of x, so y of x is equal to x fourth plus 9x squared. Like, why did I need to do that? Because the question specifically asks for dy dx. That means use x as a variable, not like y as a variable. So u as a variable. So I couldn't use it directly like this. I have to convert to in terms of x. So once I have this, then everything else is kind of like what we did before. Dy dx is basically like y prime is 4x cubed comes from here, and then plus 18x squared that comes from the second term. And then the next one is 18x, right? Okay, so that's my dy dx, right? So it needed extra work, but it wasn't too bad. I have a side question. What if the question was to find dy du? So here they're saying use u as a variable. Well, okay, use u as a variable, then it's just u squared. So that'll be pretty straightforward. That'll be just 2u to the 1 power, which is just 2u, that's it. So it depends on what the question is asking. If they're saying to use u as variable, that's it. And I don't have to do any extra work. Du dx, again, it's like take the derivative of u function. This is my u function. Use x as variable. Okay, so that's just straightforward derivative also. 2x plus 3. Okay. Now let's look at some slightly more complicated question. What if y was like u to the 10th power? If I was going to do y of x, I can kind of do the same thing, x squared plus 3x to the 10th power. Here, notice this 10th power. I'm going to make it into red. If it's 10th power, how am I going to suppose to write this out? This like this, and then x squared plus 3x all the way x squared plus 3x 10 times. It's going to be very complicated. It's going to be hard to calculate for me directly, right? So, but fortunately, we have the chain rule. It'll make us, so that we don't have to go through all this middle process. We can get a like formula to be able to find the derivative still. So let's look at the chain rule here. It says f and g are differentiable functions. So first of all, they have to be both differentiable function. The big F is f decomposed with g. The little dot, but it's not dot, but there's like a circle with inside empty. That means the composition. That means you're plugging in g into f. So another way to see it is this is also f of g of x. That means you're plugging in one function inside the other function as a variable. So it's kind of like here. This thing that we calculated, I can think of this as y of u of x, right? Because we plugged in u of x into y, and this is what we got. Right? So this was composition of two functions. So basically, that's what we have here. G of f of x, f of g of x. Sometimes you can write it as f composed with g of x. And the derivative is, you notice that you take the derivative of f, leave g as is, don't do anything, and then multiply g, the derivative of g, right? Sometimes I'm going to refer this one as outer function, and whatever goes inside is called the inner function for obvious reason, inner function. And then, so this is the derivative of outer function. Outer function, take the derivative, and then you multiply that by inner function derivative. Right? So you take the outer function, take the derivative, leave the inner function as it is, so don't do anything, times the derivative of the inner function. Okay. There is the explanation I just talked about. So you want to differentiate the outer function, kind of repeating myself, at g of x, and then multiply the derivative of the inner function. Okay, so let's revisit the question we worked on. So here, so again, we already did it, but here I'm going to try to do it by using chain rule. It's going to give you, it's going to save a lot of time. So square function is the outer function. And then what's going inside is the inner function. Maybe I can use the blue one. So again, how I was going to know that this is going to be the one that we have to use the chain rule? Here I have a square function and I have x squared plus 3x function like composed. So square function is like out, and then inside it's not just x squared. If I just have x squared, then I don't have to do it. It's just straightforward derivative. But instead of saying x squared, it says x squared plus 3x. There's another function inside, right? So in this case, I'm like, in my head, I'm like, okay, this is where I have to use the chain rule. So the y prime is basically outer function derivative. Take the derivative of outer function. So derivative of a square is 2 to the 1 power, right? And if you kind of go back to the formula here, inside it says first one inside g, just leave it as it is, right? So inner function, just leave it as it is. So I'm not doing anything. So inner function x squared plus 3x. Didn't do anything to the inner function. So that's the derivative of outer function. Outer function derivative. And then times the derivative of inner function, right? So I'm looking at this, derivative of the inner function. So inner function here is x squared plus 3x. If you take the derivative of that, I get 2x plus 3. So that's 2x squared plus 3x times 2x plus 3. That's it. Okay, so this is what I got, but previous answer I got was this one, right? Where is it? Previous answer is this one, 4x cubed. So how come I get different answer? I want to make sure that I have actually the same answer because we solved the same problem. So I want to make sure that we actually have the same answer. So let me work out example 2. Answer is here, but let me kind of work it out a little bit more. So that's, I'm going to fold this out. So that's 2x cubed plus 3x squared, and then plus 6x squared plus 9x. This will be just 9x squared. Now I can distribute 2 here. So that's 4x cubed plus 18x squared plus 18x. Okay, so that's exactly actually the same as what the answer we got before. 4x cubed, 18x squared plus 18x. Here, 4x cubed, 18x squared plus 18. Okay, good. So they give the same answer. All right, so in here, we already talked about it. What is outer function, squared function? And then what was the inner function? X squared plus 3x. Okay, let's look at example 3. Find y prime if y is equal to this to the 200th power. So this one, there's no way I can like expand out 200th power. There's going to be too much. But we're going to kind of do the same thing. This is my inner, and this is my outer. Okay. So y prime is, you find the derivative of outer function first. So what's the derivative of 200th power? That's 200 to the 199 power. And then again, the chain rule says leave it inside, don't change it, times the derivative of whatever is inside. So this is outer derivative, and then inner derivative is 2x plus 3. So inner derivative. Okay. So that's it. Here, it's going to be hard for me if I it's going to be hard for me to simplify anymore. So this will be my final answer. All right. I'm going to have you guys work on number 4 and number 5. Let's get started on number 4. I'm going to have you finish it. So again, I see number 4, I see there's u, and then u is x. So first they say y of x. So write y in terms of x as a variable, whereas the original function y has u as a variable. So I'm going to rewrite y. So y is equal to secant of u. But then u I know is x squared plus 3x. So I'll write that as y is equal to secant x cubed plus 3x. So here I'm going to have you identify the inner function and the outer function and then go from there. And for number 5, same thing. I'm looking at this and this. I'm going to give you a little hint. I see it written as like this, tangent cube of x. Again, for trig function, this means tangent of x to the 3rd power. So this literally means that. So that's my hint. So you figure out which is the inner function, which is outer function, then go from there. And once you're done with example 4 and 5, we'll look at the next line. All right, if you're done, if you're going to check your answer, answer for number 4 is dy dx should be secant x cubed plus 3x tangent x cubed plus 3x times, I need more space here, 3x squared plus 3. So that will be the answer. I don't think we can simplify that anymore. For number 5, if you did it correctly, dy or y prime, which is basically dy dx, should be 3 tangent x squared times secant squared x, which is, if you rewrite it, it'd be like this. All right, so let's look at the next line here. In general, if you have the power function, if something to the some power, but whatever is inside is just not x to the 10th power or x to the 20 power, but it'd be some crazy stuff to the some power, then the derivative will be basically n u of x n minus 1 times u prime of x, right? So take the derivative of nth power, leave inside as it is, and then times u prime. Okay. I'm going to have you try example 6. This one involves multiplication product rule and chain rule together. So this one is going to be a little messy. It involves the product rule and the chain rule. Right. So this is kind of like my F. This is kind of like my G. So if I get you started, it'll be like F prime times G plus F times G prime. But to find the F prime, I have to use the chain rule, right? And then G is here plus F is here. To find the G prime, I have to use the chain rule. So this is like where I have to combine the product rule and the chain rule together. So I'm gonna have you work on that. Also number 7 as well. Right, so if you're done with 6, I hope you took your time and like worked it out actually, because it could be kind of confusing, a lot of steps. What I got for number 6 is 4x cubed plus 2x minus 1, 3x squared plus 2, x squared plus 2 to the 5th power, plus x cubed plus 2x minus 1 to the 4th, 5x squared plus 2 to the 4th times 2x. And you don't like this type of question, you know how you can see how the answer can get pretty messy. You don't have to try to simplify it. This will be fine for me. I'm going to also have you work on number 7a, and then let's do 7b together. All right, for 7a, if you're done with 7a, the answer should be f prime is equal to secant squared x cubed plus 3x squared times 3x squared plus 6x. That should be your answer for part A. Part B, let's work it out together. So I see sine of something, and then I see the radical function. Sine is like inside the radical function, so radical function would be in my outer. So I'm going to rewrite this like this: sine x squared plus 3, the whole thing to the 1/2 power. So this will be my outer function, and then this will be my inner function. Okay. So h prime of x is, I'll take the derivative of the outer function, so 1/2, and leave the inner function as is, negative 1/2 power, right? So this is outer to the derivative times the derivative of inner function. So inner function is sine of x squared plus 3. It's not sine x. I have something inside the sine again. So what? This has another inner function. So this is inner function to the inner function. Because I was going to take derivative of sine of x squared plus 3. I know how to take the derivative of sine, but this one is sine x squared plus 3. So that's like another inner function. So I want to take the derivative of that. So derivative of, now sine is like an outer function, right? So, I need more space. Let me rewrite it here. So 1/2, I'll just copy this. 1/2 sine x squared plus 3. Now I have to take the derivative of this. So that's cosine of x squared plus 3. Now I'm taking the derivative of inner function, like the most inner function, which is the x squared plus 3. So I'll get, what do I get? 2x. Yikes. So this one actually involves 3 steps because there are 3 layers of function. So square root function was the most outer function, and then there was a sine function, but x squared plus 3 was like most inner function, right? So I had this, and then have this, and I have this extra, right? So this one may be a little bit more confusing just because there are 3 layers of functions, but which is fine. We just keep doing it, right? All right, so, and then that's that, and I'm gonna have you try number 8. Equation of tangent line, so you know what to do. Basically, you have to find the derivative, and that gives you a slope of the tangent line, and then, and here I actually meant to say, this will be a little bit easier, x is equal to 0. I meant to say x is equal to 0. So if you actually did that, so that gives you 0.00. When I plug in 0 into sine 0 is 0, so 0 squared is 0. You get that? So I have you pause and finish example 8. And when you're done, if you did it correctly, your answer must, y is equal to 0. It's basically the answer. horizontal tangent line at 0, 0. So, okay, I think we're done with this worksheet.